In this lesson, we are going to explore depth of field and focal length. Before I got into photography, and before I had a digital camera, I was chatting with a friend of mine at work. We were taking some headshots of the staff, and he had some interesting comments. Because he went to school for film and video production, I took his word as truth. What he said was that if we wanted to have this blurry background in our photos, we needed to zoom the lens all the way in. What he was saying was that a higher focal length had a smaller depth of field. We shot these photos with a crummy 3 megapixel Kodak point and shoot camera, which at the time cost $400 or $500. This idea of higher focal length and smaller depth of field seemed to work. Although the photos didn't have a super out of focus background, they definitely looked more out of focus compared to how a layman would normally take these photos, which would be from about 2 to 3 feet away and using a much wider angle. Here's the thing. The photos didn't actually have a drastically smaller depth of field. It only looked like they did. Now, you might be confused by what I just said, and I admit that it was a little confusing. But this is why I want to talk about this relationship between depth of field and focal length, because there's a lot of misunderstanding about how it works. Let's jump into our depth of field calculator and see what's going on. So let's see what happens when we take our depth of field calculator and we increase our focal length and leave everything else the same. So let's start with, let's say 72 inches for a distance to our subject. And let's put 25 millimeters in as a focal length just to start. So we can see at this focal length and this distance to our subject, we're going to get about 2 feet total depth of field. Now, if we increase this to, let's say 50 millimeters, look at that. We get just about a quarter of that. If we go to, let's say 100 millimeters, this goes down even further, almost a quarter of that. And if we go to, let's say 150 millimeters, we get down again. Now we're at 0.6 inches of total depth of field. At 200 millimeters, we're looking at 0.33 inches total depth of field. So there definitely is a difference in depth of field when we change the focal length. But here's the catch. We didn't just change the focal length. We also changed the composition of the photo. A photo at 6 feet with a 25 millimeter lens looks a heck of a lot different than a photo at 6 feet with a 200 millimeter lens. What if we were to make our subject look the same in all of these tests? This would be just like my story at the beginning of this lesson, when we were taking headshots of our staff. When we increased the focal length to get that blurry background, we were also backing up to compose the photo so it looked the same. Let's jump back into the calculator and look at the numbers again. Let's change this around a little bit, and this time we're going to add the numbers that would be similar to if we increased the focal length and we backed up to recompose the photo so that the subject looked the same. So we start off with 25 millimeters at 6 feet away, and we get about 2 feet total depth of field. Now we go up to 50 millimeters, and because we doubled that, let's double this to 12 feet. So we're going to be 144 inches. And look at that. Our depth of field is almost exactly the same. We were at 1.99 before, now we're at 1.95. If we go again to, let's say 100 millimeters, we're going to have to pull back again. This time we'll be at 288. And look at that. The depth of field is almost exactly the same, 1.94 feet. I mean, it's very, very close. If we go to 150 millimeters, now we're going to have to go to 36 feet, and that's about 432. And look at that. The depth of field is exactly the same. If we go to 200 millimeters, we're going to go to 576 inches, which is 48 feet, to recompose the photo to get the subject about the same size as it was when we first started at 25 millimeters and 6 feet. And you can see here that our depth of field is exactly the same. So by pulling back and recomposing the photo so that the subject is about the same size, it doesn't drastically affect the total depth of field in our image. What we find is that even though the depth of field is about the same, the pictures look different. This is because when we use a lens with a higher focal length, we are seeing less of the background and then stretching it across the frame. This effect that we are seeing is a more narrow field of view, and it's not exactly a smaller depth of field, although it has a similar effect of providing more isolation of our subject by seeing less of the background. With that in mind, you are ready to move on to the next lesson, where we will talk about depth of field and sensor size.